Now, the point of all what we've done up to this point was to turn this into this. Now we can solve this exactly like a 3x3, because if you think about it, we could treat the 4 in the center as one center here. We could treat each edge pair as one of these, and corners obviously will work as corners. So as long as we never move the cube like this now, by like separating centers and separating edge pairs, we could solve it exactly like a 3x3. All you have to do is just always move the edges together, never break up an edge pair. So first we're going to do the first layer, just like a normal 3x3. I'll start with whatever. I'll start with red. So let's bring, I'll do the cross first, the equivalent of the cross on a 3x3. So there's red, white. You should, by the way, already know how to solve a 3x3 if you're watching this video, or if you're trying to solve a 4x4, because I mean this whole section of the solution is solving the 3x3 in just a bigger equivalent. So let's see, we want the red green here, so I'm going to bring that up. If you already know how to solve a 3x3, you should be able to follow what I'm doing. If not, I'm just solving the first layer of the way a 3x3 would be. Okay, so there's the cross, and the equivalent of it. It looks fatter, but that's just because, again, we have 2 instead of 1 edge pair. So, and then we're going to bring up the corners. There's one corner. So now what I was talking about in the very beginning of this video, this set of videos, when I said when we were building the centers, if you didn't build the centers in the correct orientation from each other, then the colors on the corners, the stickers on the corners wouldn't match up with the centers, because like there was no guarantee that there was going to be yellow here, green here, and red here. You had to build them that way so that the corners will all match up. So if you're at this step and the corners don't match up, like if you have red here but it's yellow green, you're gonna have to go back to the beginning. That would suck, but that happened to me a few times when I first learned how to do this. You always have to build the edge pairs in the correct orientation from each other, or else the rest of the cube won't work. Alright, so next I'm gonna solve all the corners in the first layer, or the equivalent of the first layer. Don't worry if your 4x4 gets stuck very easily. It's just because it has more pieces. I actually find that the 5x5 over here is smoother than this one. I don't know why. Maybe it's just this cube. Okay, so that's the equivalent of the first layer. And so next step is to solve the second layer, which is filling in this edge. On a 3x3, that would just be just one of these, like that one right there. This piece right there, but instead there's 2. But it doesn't really matter. It will be the exact same algorithm. So let's see. So first you're gonna make the T. If you do the cube this way, some people solve 3x3s different way, but in a layer by layer method you do it this way. If you want to learn that way, if you want to be able to follow what I'm doing right now, you can watch one of my 3x3 videos. I explain it on the 3x3 the way I'm doing it right now. So when you look on the bottom, white, and so white's over here, so you do the same algorithm as on the 3x3. Okay, and then at this point I want to let you know that if you have any outstanding problems that you can't seem to find any solution for in my video, you can email me at dannyb21892 at verizon.net. That's DANNYB, the letter B, 21892 @Verizon.net. A lot of people did that with my 3x3 video, and what they didn't understand from the video, I helped them with in an email. And they all emailed me back saying, "Thank you, now I understand it." So I can, or you can just comment this video, but if you'd like a more detailed explanation of some of the stuff, then you can email me. Okay, so now we're going to do the equivalent of the third layer on a 3x3. Some stuff can happen here that can't possibly happen on a 3x3, but the first step, solving the corners, is exactly the same. So you can see that this corner and this corner need to switch. So again, it's the exact same algorithm for switching corners on a 3x3. Okay, and these two corners need to switch. Again, the same algorithm as on a 3x3. Okay, so next is to solve the corners. Once you've put them in the right place, the next step is to orient them. Same exact thing as a 3x3. You look for the patterns. So I have those two there. Same algorithms all up to this point. Okay.